Hello everyone, this is Abdullah Mamun. I am presenting our AAAI student abstract, Domain-Informed Label Fusion Surpasses LLMs in Free Living Activity Classification. The motivation behind our work is the challenges associated with datasets collected in free living environments. For example, undefined activity vocabularies or noisy labels which create inconsistencies across different participants for similar type of activities. Our proposed framework FuSE-MET overcomes these challenges by taking consideration of semantic similarity and physical intensity of the labels, and then grouping similar labels into similar clusters. The semantic embeddings are created with a BERT-based encoder that takes a word or phrase and creates a 784-dimensional semantic embedding vector. The domain-specific knowledge is integrated with the MET decoder, which takes the normalized MET value of an activity and then creates a 784-dimensional MET embedding vector. Then a lambda-weighted fusion is applied, which is basically the weighted average of the semantic embedding and the MET embedding, and it is determined with the hyperparameter lambda that represents the priority given to the domain knowledge compared to the semantic embedding. And then unsupervised clustering is applied, and in this case you can see that 5 different clusters are created. Bathe, eat, getting haircut, they belong to the same cluster. Then clean, cook, dog walk, they belong to another cluster, and cycle is in a different cluster by itself. Our method was evaluated on a dataset collected from participants with cardiovascular diseases. The classifiers used were random forest, one nearest neighbor, SVM, XGBoost, DNets, and a few others. The baselines were GPT-4-based clustering without MET values, followed by one of these classifiers, and also non-fusion model with 36 different clusters where no k-means clustering was performed. We found that FuSE-MET outperforms the baselines in both accuracy and F1 score. In this table, we display the best results achieved by FuSE-MET and also the best results achieved by the baselines for different values of k. And we see here that FuSE-MET is outperforming GPT-4-based clustering in all 4 different values of k. To summarize, FuSE-MET overcomes the challenges of noisy labels and undefined activity vocabulary by considering semantic embeddings and physical activity intensity, and then performing unsupervised clustering. Thank you so much for listening to our presentation. If you have any questions, feel free to reach out to any of us. And also don't forget to look at our code on GitHub.